Hey everyone, welcome to the video. Today we will be doing right shifting on the port C register of the PIC18F45K20. So this is an 8-bit register, so we'll see 8 executions. If you've seen my previous video with left shifting, it's very similar. We're just going to be doing the reverse of that. So we've got our schematic here, PIC18F45K20. As always, the 20 MHz crystal, 218 picofarad capacitors. On port C, we've got a green bar graph LED connected with a 15 ohm resistor network in between to limit the current. We've also got the pin RE3, which is the master clear pin, pulled up to VDD, which in our case is 3.3 volts. So this is a 3.3 volt mic controller, if you don't know. Like my previous video, I've got a little document set up here showing how the execution works. So as we'll see later on, when we execute the code, in the first execution, we're loading the value of the register with 0x80. So we're enabling pin C7, which is this one. We're then right shifting by a position of 1. So in the second execution, pin C6 would be lit up. And then again in the next execution, pin C5, then C4, C3, C2, C1, C0. And then on the 8th execution, we have an if statement which activates. And essentially what this does is it reloads the register with the value 0x80 and the cycle continues again. So that's how the code works. I'll now show you how to set up the programming environment. So I've already got the example here, but if you want to make the project yourself, go to File, New Project, Microchip Embedded, Applications Project, Next. Type in PIC18F45K20 into the device. I'm not using any tools, I'm using Proteus, but if you are using a device, you can select here. Once you've connected it, it should show up. Then you click Next. I'm using XC8 version 2.46. Click Next. You can call the project whatever you like. Remember where you saved it. Make sure that it's set as the main project and you open MCC on Finish. Click Finish. Just give it a couple of moments. So we select MCC Classic Content. Click Next. Okay, so first thing we want to do is configure our system module. So as we're using an external 20 MHz clock, we need to configure that. So we go to Oscillator Select, HS Oscillator, System Clock Select, that's correct, FOSC, External Clock 20 MHz. The reason for this is in our code, we have delay functions, so we need to tell the software what our clock frequency is. And that's what you need to do for this. Interrupts, not interested. Pin module, so we need to configure our pins. So we go to pin module, GPIO output, go to the port C column and activate these locks. You can see it's and that's what you need to do in this interface. So you can click and generate on this button and you should get a message shortly saying complete, like so. And you click MCC once and you exit the interface. So now that's how you set up the project. So now I'll just go over the code just to explain it further. So we've got our default code, for example, including the necessary generated files. So that's taken from the MCC default code. We've then got our void main function here. So we're initializing our system. So for example, setting port C as an output. Now, this is the code we're interested in. So we're setting lat C equal to 0x80. So essentially we're illuminating the last pin, RC7 here. We then enter this while one loop where we have a short delay so that we can see the output on the display. We then shift the latch register by 1. We then have this if statement which is only activated in the 8th execution, so we'll ignore that for now. So we'll then loop around the code back to here. We have a short delay, so we then see that our latch is now in position 0x04. So then we would have this LED illuminated, and then that continues until we get to latch being equal to 0x01. So that's the 8th execution in which the if statement activates here. We then have a short delay here so that we can actually see the 8th execution. And then after the delay function, we then reload latch with 0x80, which in our case is the last LED turning back on, which would be here, and then the cycle continues again. So that's all that happens in this code. So if we run simulation, you'll see the output. So we'll start here, and we'll go in steps of 1 till we get to here, where the if statement activates, and then return back to here. That's it for today's video. Hope you found it useful. Source code and files can be found down below. Until the next time, goodbye.